Okay, so here we have to explain the concept to find the equation of a plane in the normal form. So if suppose this is the x-axis, this is y-axis, and this is z-axis, then and we have one plane, we have one plane, and on it we can take some point P on that plane. P is any arbitrary point which is having the coordinates x comma y comma z, and this is the origin which whose coordinates are 0 comma 0 comma 0, and we take the foot of the uh, perpendicular, we take the foot of the perpendicular from the origin on that plane. That point is n. So on vector is perpendicular. Suppose on vector is perpendicular to the plane, from the origin, from the origin. It means that point n is the foot of the perpendicular from the origin on that plane, and is the foot of the perpendicular from the origin, on that plane. So, and if the perpendicular distance of the plane from the origin is suppose d units, and also if suppose the perpendicular distance perpendicular distance of that plane from the origin of that plane from the origin is d units. Suppose it is d units. Uh, then then the unit vector along the normal from the origin, then the unit vector along the normal, unit vector, then if the unit vector, sorry, if the unit vector along the normal on vector is suppose n cap, then this magnitude of on vector, that should be obviously d units. So the on vector can be written as d times n cap. So now, since the on vector is perpendicular to the plane, let's say the name of the plane, if I call it as pi 1, so on vector is perpendicular to the plane pi 1, so the p np vector should be also perpendicular to on vector. Since why? Since np vector lies on the plane pi 1, lies on the plane pi 1. So np vector will be this. So now np vector, that should be obviously equal to op vector minus on vector. So now op vector is obviously the position vector of the arbitrary point on this plane, which is, this is op vector. So this op vector, we can call it as r vector also. So now np vector, that should be obviously r vector minus this on vector is d into n vector. So np vector is perpendicular to on vector. Hence, we can also say that np vector dot on vector, that should be equal to 0. Therefore, np vector is r vector minus d into n vector. Then its dot product with on vector, which is d into n vector, that should be equal to 0. So now we can cancel out d since d is not equal to 0. So r vector minus d n vector n cap dot n cap, that should be equal to 0. So then, so we can write r vector dot n cap minus d into n cap dot n cap, that should be equal to 0. So now n cap dot n cap, that should be equal to 1. Since the same unit vector, we are taking the dot product of this. So n cap dot n cap will be 1. So therefore r vector dot n cap, that is equal to d. So this is the required vector equation of the normal form of the plane. This is the required vector equation of the plane pi 1. This is the vector equation of the plane pi 1 in the normal form. So now, how to write this in the Cartesian form? So now, if the direction cosines along the normal vector on, so now if the direction cosines along the normal vector to the plane, along the normal vector to the plane from the origin, which is on vector, are given as L, M, and N. L, M, and N. Then obviously the unit vector along the normal, which is n cap, that can be written as Li cap plus Mj cap plus Nk cap. So therefore, this we can write it as, and r vector is obviously xi cap plus yj cap plus zk cap, which is the position vector of the arbitrary point P on the plane. So therefore, so we can write r vector dot n cap, that is equal to d. So we can tell that xi cap plus yj cap plus zk cap, then dot product it with n cap, which is li cap plus mj cap plus nk cap, that should be equal to d. So therefore we can say, if we take the scalar or dot product of this vector with this vector, then we will get lx plus my plus nz, that is equal to d. So this is the required Cartesian form of the equation of the plane in normal form. This is the required Cartesian equation of the plane, Cartesian equation of the plane pi 1 in the normal form. Okay, so we can understand this by using the solved example. It is uh, suppose it has been asked to find the vector equation of the plane. Suppose here the vector equation is also asked and the Cartesian equation also. Find the vector and the Cartesian equation of the plane, which is at a distance, which is at a distance of 6 by root 29 units from the origin, 6 by root 29 units from the origin, and the normal vector from the origin is, 2i cap minus 3j cap plus 4k cap. And then it is asked also, okay. So then, okay, so how to solve this? So here the plane has been given, and here is the origin, suppose, and the perpendicular distance of this plane from the origin, this d is given as actually 6 by root 29 units, and the normal vector, which is the on vector, where n is the foot of the perpendicular from the origin on the plane by 1. So now, therefore, this unit vector along on vector is obviously, we know that is d n to n cap. So here, so that is given as 2 I cap minus 3j cap plus 4k cap. So n cap, that will be equal to the magnitude of on vector, means n cap is the unit vector in the direction of the normal vector from the origin, means n cap is the unit vector along on. N cap is the unit vector along on. So that would be equal to on vector divided by magnitude of on vector. So that would be equal to 2 I cap on vector is d into n cap. So that is actually means the normal vector from the origin is this. So the magnitude of this, so we need to find first the unit vector along this. Actually, okay, this is actually n vector. Sorry, there is something wrong. This is here actually on vector. Here it is told that it is along the normal vector, which is n vector. So means on vector is parallel to another vector n vector, where n vector is given as 2 I cap plus 2 I cap minus 3j cap plus 4k cap. Okay. So it means that on vector, that should be equal to d, which is 6 by root 29 into n cap. So now we need to find n cap. N cap will be obviously n vector by magnitude of n vector, where n vector is given as this. So now, therefore, n cap, that will be equal to 2 I cap minus 3j cap plus 4k cap divided by magnitude of this. So that will be square root of 2 square plus 3 square plus 4 square. So therefore, n vector will be equal to n cap, that will be equal to 2 I cap minus 3j cap plus 4k cap. That would then that divided by 4 plus 9 plus 16. So that is root 29. So it is 1 by root 29 into 2 I cap minus 3j cap plus 4k cap. So this is n cap. Now we know that the vector equation of the plane, the required vector equation, is obviously r vector dot n cap, that is equal to d. So therefore you can say that the equation will be r vector dot n cap, which is 2 by root 29 I cap minus 3 by root 29 j cap, then plus 4 by root 29 a cap, that is equal to d, which is 6 by root 29. Or we can write it as, r vector dot 2 I cap minus 3j cap plus 4k cap, that is equal to 6. Since 1 by root 29 we can take it as common from both sides, and that will cancel out. And then so this is the required vector equation of the plane. This is the required vector equation of the plane. And we need to find the Cartesian equation also. Therefore, R vector is obviously xi cap plus yj cap plus zk cap. So if we take the dot product of this, then therefore the Cartesian equation of the plane will be Cartesian equation of the plane, that will be 2x minus 3y plus 4z, that is equal to 6. So this is the Cartesian equation. So these are the two answers. Thank you.